Good morning, friends, and welcome to the first lecture. As I said, today we'll be mostly concentrating on particle physics in this course. So today's lecture would be some sort of an overview uh, of the history of this field. I cannot go into the great details of this, but what is the history of this field, and try to bring it to the present level. What are the kind of questions or something which we are going to answer up to the latest discovery of the Higgs boson. Uh, while I don't claim that I can give you all the details of the history, which is quite difficult, uh, what I'll try to do is give some sort of picture of what these discoveries are, because each of them is an extremely engaging and interesting story on its own right. But to get an overview of the field, I think we can look at what this is, and we'll see how it goes. So to start with, what is particle physics? So what is particle? Typically you hear the story that, okay, particle physics is the physics which tries to explain the most fundamental interactions of fundamental particles which nature is made up of, and their interactions between them. Essentially, that's the basic definition which you keep hearing. But at the crux of the problem is at the in depth, what is happening, what is the phenomena we are going to study. These are the phenomena. While there is a philosophical approach for it, but the detailed phenomena which we are trying to study is a phenomena where the substructure of the matter becomes very important. So particle physics can be re-expressed as a study of phenomena where the substructure of the matter becomes extremely important. So there is no other explanation unless you assume some sort of a substructure for this matter. Okay, there are several examples which you can immediately think about, essentially like the Rutherford experiment and everything. So these are experimental phenomena which believe that which can be only be explained by assuming some sort of a substructure for this matter. Now there is a philosophical approach. The philosophical approach is that goes under the name that reductionist approach, so which says that all the matter can be understood in terms of very few small number of particles. This has been a very old philosophical approach, essentially. The Greeks had it. For example, they tried to assume that all the matter is assumed in terms of four basic elements, which are earth, air, water and fire. This was in the BC 3,000-4,000 years ago. But the Indians also had it. Indians also had, in addition to these four elements, they had something called Panchadhatu, which also included sky in it. These four or five elements, depending upon whether you consider Western philosophy or Eastern philosophy or Indian philosophy, form the basic constituents which made up all the matter in the world. And that led to some sort of, much later, it led to something called alchemistry, which is essentially trying to get understanding between various elements and trying to create all the elements into gold and all kinds of business, essentially, which led to the discovery of the chemistry, essentially development of chemistry. Only in the late 1900s, the electron and proton were discovered, and much later we have this quarks and leptons, which subatomic particles, which came up. So this graph essentially is some sort of what seems to be the basic constituents of matter in terms of the timeline. Essentially, as the time increases, the basic constituents of matter seems to be changing. So today we have quarks and leptons. I don't know what happened. Now this reductionist approach has been there for a long time. So initially it was not extremely, so people initially thought that everything is made up of some atoms. Say for example, this idea of that everything could be made up of some corpuscles or some atoms has been there for a long time. It has not been extremely popular actually. because it seems Aristotle and Plato didn't like it. But this has some origins, but this has became popular much later in the 1800s when Dalton started looking at pressures of gases and started measuring how the pressure is coming and various ratios and everything, and that's how he came to discover the atom actually. So the atom structure came up much later. Now particle physics try to understand the atomic the fundamental constituents in terms of a reductionist approach. So you try to understand phenomena in which you need the substructure, as I was mentioning it, but there could be an phenomena in which you need the collective nature of these particles, okay, like for example in nuclear physics. So when all the particles start acting like some sort of a collective behavior, so in that the reductionist approach will not really play a role, so it will be like a holistic approach. And like for example it happens in condensed matter superconductivity, the two electrons will start acting like one single electron, single particle. There are quasi particles in superconductivity, various kinds of quasi particles in condensed matter physics. So philosophically there is a difference between the way more than philosophically, the kind of phenomena which people are interested in condensed matter and in say for example particle physics seems to be slightly different. While one is probing for the deeper and deeper structure, other one is looking at more collective behavior of the particles essentially. But underlying physics phenomena are same, and there are very deep connections between condensed matter and particle physics. That's an extremely important point to say. For example, there is also collective behavior which is very important in particle physics also, because at the end of the day everybody is trying to understand nature. Now with this let's so the first particle which has been discovered, typically you say that it is an electron. Now the electrons were discovered by J.J. Thomson in cathode rays. So you have seen this discovery of the electrons, and you can see for a while there has been this is typically known as the first fundamental particle ever discovered. This has been discovered by J.J. Thomson, as I have said, essentially. Now the story, you know that it has been discovered in cathode rays. For the second part, which essentially for the neutron and proton, you needed more activity to come up, and you needed more tools, and this was provided by the discovery of radioactivity by Henry Becquerel and Madame Curie, who discovered radioactivity in uranium, and also by Madame Curie in polonium and in radium. Radioactivity at the end of the day discovered three kinds of radioactive rays: alpha, beta and gamma rays. Now in the modern language we know that gammas are nothing but photons, betas are either electrons, positrons, and alpha particles are nothing but the helium nucleus. These the entire study of radioactivity led to the understanding of weak interactions in nuclei and at the fundamental level essentially. And also since Madame Curie provided all the tools to study and manipulate these rays, actually they provided us the tools to study the structure of the atom. So this discovery of the radioactivity played an extremely important role, and of course the importance of Madame Curie, who provided all the tools and various things for this. So along the way we have this famous Rutherford atomic model, which was essentially based on experiments by Geiger and Manson. So you know the experiment here, that you have a source of radiation which goes and hits a thin gold foil and also it was repeated with silver foil, and the result, and after passing through this thin gold foil, and uh, the rays come out and hit along the scintillations around the entire almost 4 pi degrees essentially, okay, around the experiment, around the detector. There is some sort of a scintillation detector around it. Now these experiments were done by Gregor and Martin under the leadership of Rutherford, and based on these experiments, Rutherford concluded that the atom should not be like the model of J.J. Thomson, which was almost like a plum pudding like model. No, you must have all studied it in your modern physics course, where there is the electron is completely distributed along with the protons in the atom, like some sort of a pudding in which there are all these electrons and protons all distributed equally and forming an atom. Now, Rutherford, based on these experiments and studying, because he could study the differential cross section of this experiment, you all know the Rutherford scattering experiment and the things, he could conclude that the atom has a substructure, and the substructure is not the way it has been proposed by J.J. Thomson, but where the nuclei is completely sort of within the center of the atom, completely closed within the center of the atom, whereas the electron cloud is spread all over the place essentially. So I gave you a link of the original paper of Rutherford in that previous slide actually. Now the discovery of the structure of the atom with the nucleus like a structure, and then there is a cloud of electrons a bit far away, and it's not something which is distributed. Now they also wanted to understand what is the nucleus contains, because the nucleus of the hydrogen atom is not the same as, say for example, the helium atom. There should be, and it only has 2 powers extra in atomic charge, but it has more weight essentially. It has something, so there should be some neutral particle around with it. The idea of proton was there for a long time actually. The proton was concluded to be the hydrogen nuclei for a long time, and they discovered that hydrogen like nuclei in other nuclei by Rutherford actually. In 1917, it was conclusively shown that hydrogen nuclei, which is a positive nuclei, was present in other nuclei. So there is a universality in it. So they call it as a proton. Neutron was discovered in again studying radioactive sources, bombarding alpha rays on some particular targets, and these particular targets emitted some other rays, and these rays have certain properties which are not like gamma rays essentially. Okay, so James Chadwick explored them and understood them these to be some sort of a neutrons, and this is the original paper in which he proposed the idea that these are neutrons. With putting together the proton, neutron, and now the electron, together we have now the structure of the atom in this particular fashion, that at this particular point, so we have this fashion in which there is a central nucleus which contains neutrons and protons, and then there is an electron cloud around with it, which has which keeps moving around and everything. So at this particular point, the fundamental particles of nature are just electrons, protons, and neutrons. So I'll stop here and continue with the next slides essentially.